My dear friends, on this occasion we will learn how to load our first program on the ESP32 development board, in this case a 38-pin board, learning in the process, the installation of its drivers, the installation of its resources in the development environment, and the considerations what must be taken into account when uploading programs to this. The affordable ESP32 board, less than $10, features the powerful ESP32 chip, manufactured by the China-based company ESP32, which has Wi-Fi and Bluetooth connectivity capabilities, making it ideal for developing embedded electronic projects or systems with Internet connectivity, or IoT. For this practice, we will place the board on a small 400-point breadboard, and through a USB to micro USB cable, we will connect the micro end to the board, and the other end to the USB port of the computer. In our Windows operating system, we go to the File Explorer. In the Computer option, we right-click and access Properties. In the Configuration window we access the Device Manager link, and in the Other Devices option, we can see that Windows detects the device corresponding to our ESP32 board. However, it does not know how to work with it, placing a yellow exclamation mark, since it does not have the driver for it. Windows tells us that it detects the CP2102 chip, which corresponds to this square-shaped chip located on the ESP board, and which is responsible for converting data from USB to serial, and vice versa. And that finally creates a physical communications interface between our computer and the ESP32 chip located on the board. To install the driver for this chip in our Windows, we go to our Google search engine or the one of your choice, and search for CP2102 driver download. We can enter any link. For my preference I will enter the Polola link. And here we can find the drivers for Windows operating systems, Mac systems, or Linux systems. In my case I will go to the instructions for Windows, and click on the link to download the driver for this system. Once the download is complete, I will temporarily place the compressed file on the desktop, and I will decompress it using WinRAR. With the driver folder unzipped, we go back to the Device Manager window, right-click on the device of our interest, and select Update Driver. We select Examine My PC for drivers. We examine the location where we have the unzipped folder with the driver. We select the folder. And we accept. Then we click Next until the driver installation is complete. And here we can see that Windows has finished installing the Silicon Labs driver for the CP2102 chip. We close. And we can now see in the Device Manager that Windows fully recognizes our ESP32 development board, and that it automatically assigns the COM4 logical port to it. Upon completing the driver installation, we open our Arduino IDE software. I leave you in the description of the video the link to download and install this software from the official Arduino website. In our Arduino software, we go to File. Then Preferences. And in the Preferences window, we access the icon for additional board manager URLs. Here we access the link to list the URLs of unofficial Arduino boards. An Internet window is displayed, where the resources to use boards from manufacturers other than Arduino are listed alphabetically. We scroll down until we find the resource for ESP32 boards from the ESP32 company, which has support for many variants of ESP32 boards. We copy the address of the link located next to it. And we paste it into the Arduino URL manager, separating it with a comma from the other URL addresses that may be previously pasted here. We click on Accept, and then Accept. Then we open the board manager, and in the search bar we type ESP32. We located the resource for ESP32 from ESP32. And we click on Install. It will take a maximum of a couple of minutes to install the entire package. Once the installation is complete, we can close the board manager. And we can see in Tools, Board, that we already have a new tab, with the list of all the variants of development boards for the ESP32 chip. For our case, we are going to select in the first options of the list, the one that says ESP32 Dev Module. And in Tools, Port, we select where the operating system recognizes the ESP32 board is located, in my case COM4. Only after selecting the ESP32 board in Tools, we can go to File. Examples. And we can see an additional tab with an extensive list of examples related to the ESP32, from basic examples to use its GPIO pins, to examples of greater complexity with Wi-Fi and Bluetooth connection, for the Internet of Things, or IoT. For this case, we will load the first of many programs, go to the Basic tab, and open the Blink example to blink an LED. In this Blink example, we will change the pin of the target LED towards pin number 5 of the ESP32 board, which is where we will locate the LED according to our connection diagram. So, let's extend the G5 pin of the ESP32 board on the breadboard with a jumper wire. And let's extend the GND or ground pin of the board with a jumper wire. And let's locate the LED diode, in this case red, with the anode or the longest leg towards the G5 pin, and with the cathode or the shortest leg towards the ground or GND pin. And in our software, we click on the upload icon to upload this code to the board. We can see in the system output a message that says, connecting. And finally, we get an error indicating that the program loading failed. This is because, unlike the basic Arduino boards, the ESP32 board has a boot button, with which it can enter its initial boot mode, a mode in which the board can receive new programs from the computer. Knowing this information, let's click on the upload icon again. And if we look at the system output messages, and just when we see the message, connecting, we press the start button, keeping it pressed for a few seconds. Until at the system output, we see that the memory writing process begins, indicated in percentages. Upon completing the loading of the program, we can now see the LED flashing according to our code, thus completing our first of many interactions with the ESP32 board. A special greeting from Electronic Spot, and see you in the following video.